This is a video from my Calculus 1 Exam 2 review. And the directions say to find the derivative, simplify your answers where appropriate. And with that, we're going to take a look at problem number 1. Suppose y equals x squared plus x cubed raised to the 4th power. So this is a classic chain rule problem. And so what we're going to do is we're going to let u equal x squared plus x cubed. So y is equal to u to the 4th. So notice how I express y in terms of u. Du dx is equal to 2x plus 3x squared. Dy du is equal to 4u cubed. So therefore, dy dx is equal to dy du times du dx. But dy du is equal to 4u cubed. Du dx is equal to 2x plus 3x squared. But remember that u is equal to x squared plus x cubed. So I get to now make my substitution. So therefore, dy dx is equal to 4 times x squared plus x cubed raised to the 3rd power times 2x plus 3x squared. But we're not done because we now need to simplify our answer down. And this is what we do. Now, I'm going to write this as 4 times. Now, within these brackets, I'm going to factor out an x squared from x squared plus x cubed. So I get x squared times 1 plus x, right, raised to the 3rd power. And then from here, I factor out the x and then multiply this by 2 plus 3x. So this is 4 times. Now, x squared to the 3rd power is x to the 6th, right? And then I multiply by 1 plus x to the 3rd. And then I go times x times 2 plus 3x. But x to the 6th times x is equal to x to the 7th. So this is 4x to the 7th times 1 plus x to the 3rd times 2 plus 3x. So therefore, dy dx is equal to 4x to the 7th times 1 plus x to the 3rd times 2 plus 3x. And that's how you do problem number 1. Let's take a look at problem number 2. Suppose we have y equals 1 over the square root of x minus 1 over the cube root of x raised to the 5th power. And so this is 1 over. Square root of x can be written as x to the 1/2. So I get 1 over x to the 1/2 minus 1 over x to the 5/3. But this is equal to x to the negative 1/2 minus x to the negative 5/3. Now, recall, the derivative of x to the n with respect to x is equal to nx raised to the n minus 1. So it's the power rule. And so if I want dy dx, I'm going to apply the power rule to the first term and the second term here. And so this is negative 1/2 x to the negative 1/2 minus 1, which is negative 3/2. Then I go plus 5/3, right? Because a negative times a negative is a positive. So I go plus 5/3 x to the negative 5/3 minus 1, because that's what n is for the second term right here. And negative 5/3 minus 1 is equal to negative 5/3 minus 3/3. So that should be negative 8/3. Now we can go a little bit further here. And so dy dx is negative 1 over 2x to the 3/2, right? Plus 5 over, and then it's 3x to the 8/3. And then I'm just going to put this back in radical notation, and that'll be fine. And so I get negative 1 over 2 times the square root of x cubed plus 5 over 3 times the cube root of x raised to the 8th power. And that's dy dx. And that's how you do problem number 2. Let's take a look at problem number 3. In problem number 3, we have y equals x squared minus x plus 2 divided by the square root of x. I would recommend splitting up this fraction. So I'm going to write this as y equals x squared over x to the 1/2, because that's what square root of x is, minus x over x to the 1/2 plus 2 over x to the 1/2. If I take this a step further, I can write this as x to the 3/2 minus x to the 1/2 plus 2x to the negative 1/2. Now I'm ready to take the derivative. So y prime is equal to 3/2 x to the 1/2. I'm just applying the power rule to each one of these terms. Minus 1/2 x to the negative 1/2 plus 2 times negative 1/2, right? X to the negative 1/2 minus 1, which is negative 3/2. Now we can go a little bit further here, okay? And now notice how the 2's cancel. And what I'm going to do here is I'm going to say y prime is equal to. So the first term is 3/2 x to the 1/2. The second term is minus 1 over 2x to the 1/2, right? See? That's the second term. The third term is minus 1 over x to the 3/2. So my goal here is I want to get a common denominator. And the common denominator I'm going to use is 2x to the 3/2. And so I'm going to put a 2x to the 3/2 in the bottom. Now, the first term is missing and x to the 3/2. So I'm going to take 3x to the 1/2, and I'm going to multiply by x to the 3/2, like so. The second term is missing x, so I'm going to subtract x. The third term is missing 2, so I'm going to subtract 2. So does that make sense? So if I want the third term to have a 2x to the 3/2 in the bottom, I'm going to multiply the denominator and multiply the numerator by 2. If I want the second term to have 2x to the 3/2 in the bottom, I'm going to multiply the numerator by x and the denominator by x. And that's the idea. So I'm making sure every term has a 2x to the 3/2 in the bottom. And that's what I'm doing. And so if I go a little bit further here, y prime is, the first term is 3x squared. Then I go minus x minus 2 divided by 2x to the 3/2. And that's how we simplify this. And this is problem number 3. Now, let's do one more for this video. We're going to take a look at problem number 4. So in problem number 4, we have y equals tangent x divided by 1 plus cosine x. This is a classic chain rule problem. So y prime is, so I'm going to take the bottom function, which is 1 plus cosine x. I'm going to multiply by the derivative of the top function. The derivative of the top function is secant squared x, minus the top function, which is tangent x. And then I'm going to multiply by the derivative of the bottom function, which is negative sine x. And I'm going to take that full answer and I'm going to divide by 1 plus cosine x to the second power. Now, this can be written as follows. If I distribute the secant squared x inside, I get secant squared x plus cosine x times secant squared x plus, now tangent x is sine x over cosine x. And I'm going to take that and multiply by sine of x. And then I'm going to take that whole thing and divide by 1 plus cosine x to the second. Now, what I'm going to do from here, let's talk about something right up here. Secant squared x is 1 over cosine squared x. So from here, I'm going to multiply the numerator and denominator by cosine squared x, just like this. Now, when I do that, I get the following. I get y prime is, now in the numerator, I'm going to get 1 plus cosine x. Okay, so let's write 1 plus cosine x plus, now I'm going to get sine squared x times cosine x. That's the top. On the bottom, I get cosine squared x, right, times 1 plus cosine x to the second power. And that's a pretty good stopping point. And let's make sure we understand that. So let's talk about a couple of things. If I take sine x over cosine x times sine x, right? This is equal to sine x over cosine x times sine of x over 1, which is sine squared x divided by cosine x. Now remember, I'm taking cosine squared x times every single term within these parentheses. Okay? So if I take sine squared x over cosine x, and I multiply by cosine squared x, well, I'm going to write this as cosine squared x over 1. I can cross this cosine x with one of these. And then I end up with sine squared x times cosine x. That's how I get that third term. And then to get that second term, right? So let's take cosine x times secant squared x times cosine squared x. Now, this is cosine x times 1 over cosine squared x times cosine squared x. So these two guys cancel, and I'm left with that cosine of x, and that's how I get that second term there. So, and then the first term is just really the product of these two guys, which is 1. Okay, that'll do it for this video. Thank you very much. This is the Exam 2 review, problems 1 through 4. Thank you.